join because we are in the last lecture, and at the end of this lecture, I will be requesting some students to share some kind of maybe feedback or maybe any kind of observation if you have. So that is up to you. So it is again it's optional part. It is not mandatory, right? So let's begin the discussion of today's lecture. So, and today's lecture is basically going to cover these important concept called concurrency control. So like in the previous lecture, we have correctly pointed out that in a DBMS system, to maintain or to manage the concurrent access of different user transactions or operation, because concurrency is something which we are trying to achieve, which DBMS system is trying to achieve. So basically what happens whenever we see that a database system is getting a lot of transactions, lot of user operations into the system, it basically apply or initiate some kind of DBMS activities in the background to control these concurrent transactions, right? Because DBMS system is basically there to manage each and everything. So similarly, in the similar fashion, it is the responsibility of DBMS system is to maintain the concurrency and handle all these transactions. He cannot deny, right? But yes, you can, as a database designer or maybe as a system designer, you can decide the limits on the transaction. That's why in the many real-time systems, like any examination-based system, any order processing system, you can decide a limit that only these many number of transactions can happen in a system at any point of time. That you can do, and usually in any data based processing or any transaction processing system, it is observed that each and every system will have some kind of limits, that a particular database system or particular data transaction system may handle only around maybe 10,000 number of orders, or maybe 10,000 number of tickets, or 10,000 number of transactions. So that this limit on the transactions at any point of time that you can decide or you can configure. But within that limit also, let's assume that IRCD system is basically designed to handle 10,000 number of transaction, 10,000 number of operations at any point of time. So within this 10,000 transactions which are active in the system at any point of time, you need to maintain some kind of concurrency, right? So that is sometimes it has become principal responsibility of DBMS, that whatever transactions are occurring in the system, it should be creating, it should be updating the value naturally. And after these operations, user operations, or these transaction operation, your database or your data values of the database or within the database should be in the valid state, right? Because now more than one user is operating on a particular data value. So after achieving these operations by different users, this data value should be on a valid state. That is the minimum requirement we are expecting from the system. So basically in the DBMS, like we have pointed out, within DBMS there is a separate component which is responsible for managing all these things, and this component is called concurrency control. So basically you can assume that, okay, concurrency control is a software or is an algorithm, but this algorithm is having some kind of conditions, some kind of rules, some kind of provisions, right? So because whenever we try to develop an algorithm, whenever we try to create a code for a procedure, for a function, naturally it will be following some kind of steps, some kind of set of rules. So these rules, in the case of concurrency controls, these rules are referred as a concurrency control rules or protocols, right? So so you can correctly see in the notes also, it is said that, okay, so basically achieve this concurrency control protocol or set of rules, we have some variations also. So basically concurrency control requires some kind of rules that you should be achieving these things, right? So suppose we are having more than one transaction, and suppose these two transactions are fighting for the same data object, same data item. Naturally we will be defining some expected rules, some expected conditions which needs to be ensured by these protocols or this system, this concurrency control system, right? So as a layman form, you can say concurrency control is basically a set of rules. It is nothing but it is a set of rules, set of protocols which will ensure that more than one transaction can access a data item with the objective to maintain its validity, right? So if you see, whenever we are planning to design a concurrency control algorithm, concurrency control mechanism, or a strategy or approach, you should be making sure that there will be one or two operations which might help you to achieve this concurrency, right? So basically, when we say concurrency control is a set of strategy, it is a rule or a protocol, then we can say, okay, we can have multiple approaches. So like traditionally, there are three different approaches are available for concurrency control, right? So first one is called a locking mechanism. The first approach is called locking mechanism. The second approach is called time stamping approach, and third one is called multi-version, right? So in these three different approaches, the philosophy is different naturally. Like in the case of locking mechanism, we used to create a procedure, a function which will lock the data item. Locking means any transaction which is trying to access data item X, he will initially call a function called lock data item X, and then after that, after locking the data item X, it can perform all his transactions, all his operations, right? And other transactions in a schedule who are trying to read the same data item should wait for a while, राइट तो एक ट्रांजेक्शन जब उसको लॉक करेगा उसके बाद उसमें अपने ऑपरेशंस एग्जीक्यूट करेगा, रीड राइट व्हाटएवर, एंड आफ्टर हिज टास्क हैज बीन कंप्लीटेड, द ट्रांजेक्शन T1 जिसने इसको लॉक किया था अपने ऑपरेशंस कंप्लीट करने के बाद उसको अनलॉक करेगा. Then only these other transaction out of these remaining transactions, someone will be trying to again access it, lock it, use it, and unlock it, something like that. So this is a simple mechanism. This is a very layman perception based algorithm is there within this locking mechanism. Naturally जो आपका locking mechanism है, इसमें basically broadly they used to say it is a two-phase locking. Two-phase locking means we have two phases. First phase says okay, you need to unlock it, then you need to use it, then eventually you need to unlock it. So basically there are only two phases. First phase says lock it, second phase says unlock it. So that's why it is called two-phase locking mechanism. So this first mechanism, which is called locking mechanism, so whenever you are designing a DBMS system, whenever you're designing a transaction processing system, and if you're adapting locking mechanism, so locking mechanism to achieve concurrency, then you need to define these two phases. First phase to how you will be locking, how your database system will be locking the data items, what is the function, what is the procedure of it, and second phase, how the system will be unlocking, right? So locking is one alternative. Locking is one possible option you can adapt for your system. Second option which is available whenever we are designing a data processing system or data concurrent transaction processing system to ensure the concurrency, second alternative is time stamping, right? So time stamping is nothing but timestamp is, I mean, that's how we understood also that timestamp is a value, time value, right? So as soon as transaction is appearing into the system, as soon as system is receiving these transaction, DBMS system will generate a unique identifier or unique value which might be having time value also. Like टाइम स्टैम्पिंग का जो हमारा परसेप्शन वही है कि टाइम स्टैम्प मींस टाइम वैल्यू. सो जैसे ही यूजर ने ट्रांजैक्शन स्टार्ट किया तो जो उसका टाइम वैल्यू था लाइक आवर्स, मिनट्स, सेकेंड्स एंड मिली सेकेंड्स लाइक वाइज, तो एक आप आइडेंटिफायर क्रिएट कर सकते हैं. दिस आइडेंटिफायर इज रेफर्ड एज टाइम स्टैम्प, एंड बेस्ड ऑन दिस टाइम स्टैम्प वैल्यू we can design a strategy to arrange these transactions. So naturally, क्योंकि एक database system में we could have possibly more than one transaction are happening at the same time, but then also we can assign different identifier to the different transaction. So suppose in database system we are getting 10 transaction on the same data item. Now you can assign 10 different identifier to these transactions and design an algorithm so that they can arrange, they can handle these different transactions, and you can sort out or you can manage this serializability, you can maintain the concurrency, right? So time stamping is the second alternative. The third and the last alternative which we have currently also available in the different transaction processing system in the real world, real world operations is called multi-version. And this third approach says you can maintain the multiple versions of the same data, right? So basically, multi-version approach is nothing but it is a hybrid, or it is the extended version of either time stamping or two-phase locking protocol. And in this course, particularly in this database course which we are covering in this semester, time stamping is not that important, and we are not going to discuss this on detail. But you can understand that multi-version is basically having this philosophy that whenever we are getting more than one transaction in the system, for a same to access the same data object, same data value, we can create a multiple versions of the same data, right? Right. Suppose there are more than one transaction, like T1, T2, T3 are trying to access data item X for their different operation. Then we can create multiple versions, multiple copies of the same data items, but we need to maintain some kind of synchronization, right? So after that, you can issue some kind of hybrid approach to arrange these transactions in a way, right? So we are not using, I mean, naturally, that's what we have said. The first extended version of multi-version approach, or strategy, is basically an extended time stamping approach, right? Which is referred as a multi-version time stamping ordering. So it is the extended approach of it, but difference is only on the first part. Like in case of locking mechanism, we used to use lock variable. Like in case of time locking mechanism based approach for concurrency, we use lock variables. In case of timing stamping, we use a unique identifier, right? Or in case of multi-version, we used to have multiple versions of the data item itself. So this is something on which this whole approach is based. In case of blocking mechanism, a lock variable approach is there. In case of time stamping, there is a unique identifier available. In case of multi-version, we used to create multiple versions of the same data item. So this is how these things are arranged. And first, let's go to understand that how locking mechanism basically approach works. Right. So basically, in locking mechanisms, suppose in your database system or in system, when multiple transactions are getting or raised by users, then this whole thing of concurrency control in your system, if your system is based on locking mechanism, in your system there is a variable called lock, L-O-C-K. Lock variable is created, right? And based on the status of lock variable, uh, basically these transactions will be coming into the system for these operations, coming in inside this database system to operate on the data value. So it is very important to decide how lock variable is updated and what is the current value of lock variable, right? Naturally, so whenever we say, okay, there is a variable and there is some needs to be done, or something needs to be done on the data variable, it means we have three things basically. First part is naturally the lock variable for each data item. Second, we could have operations, these operations which could be updating the log status of lock variable, right? So let's go to understand that what is the basic. So binary locking is mechanism is the first basic approach, right? So binary locking means this: if we have lock variable in the database system, the lock variable will have two possible states or values. States or value. State means, I mean, locked or unlocked, something like that. A value means you can assign a equivalent value for those variables, 1 or 0, right? So basically, in case of binary locking mechanism, which is the first solution we have for concurrency control around proposed in year 1988, somewhere between 1988 or 99. So in this binary locking mechanism, we have a lock variable, and for lock variable, we have two possible states or two possible value, whether it is 1 or 0. So 1 indicates it is logged. It is logged means whenever you say in system lock of X, so X is a data value, lock of X is 1, it means that variable is set as logged, and that data value X is being used by some transaction. Similarly, if you see any point of time, if as a user, if I am executing a transaction in the system, and if system observe that concurrency control system observe that lock of X is 1, it means it is already engaged by some other transaction. If lock of X is 0, it is basically free to use. You can use it for your transactions, right? So basically, you can do one thing from here. From transaction point of view, you can access. So if log of x is 0, it means it is available for the operation for any other transaction, and you can use and access that data item x for your transaction. So that's how it is created for use also, right? So let's understand. So naturally, if we have log variable on each data item, then we need some operation, some function to update basically data log value. So you can see, for in case of binary locking mechanism, we have two functions: lock item, right, and unlock item. So these are the two functions which we will be using, which our concurrency control system will be using, right? So broadly, if you can read lock, so the philosophy of each these functions are basically very clear. Lock item means so whenever you want to execute a transaction and concurrency control system observe that log of x data value is 0, it means it is available, then that transaction is basically is good for accessing the data item x. So once it is observed that log of x is 0, it means the data item is available for use. So after getting into the transaction, the very first step which needs to be performed by transaction is log item x. It will call a function called lock item, right? Because I mean, जैसे transaction आप login करते हैं और it is observed that data item is available to use, the very first thing is to be done by transaction T1 is to initiate the function called lock x, lock item x. तो ये एक function है, उस function का पहला काम ये होगा कि वो उसको set करेगा 1 में, so that दूसरी transaction उसको और update ना कर सके. So lock item x is a function which basically is designed to basically lock the data value so that other transaction may not use, right? और you can say कि जैसे ही आपको ट्रांजेक्शन स्टार्ट हुआ, उसके बाद अगर आप किस डेटा आइटम को एक्सेस करना चाह रहे हैं तो आप उसको लॉग फंक्शन को इनिशिएट करेंगे, क्योंकि आप उसको यूज करने वाले डेटा वैल्यू को. So basically the definition of log item x is shown here. You can read here like log item x, x is x data value, and if it is observing that if particular transaction is observing that log of x is 0, if transaction T1 is observing that log of x is 0, it means item is unlocked, it is available for use. तो immediately क्या करेगा वो, उसको log of x को x1 सेट कर देगा. It means जो भी ट्रांजेक्शन इस T1 के बाद आएंगे उनको लगेगा कि log of x 1 है, तो वो बेसिकली एक क्यू में आया कि एक लिस्ट में अरेंज हो जाएंगे, राइट? So that's what it is defined also. If log of x is 0, it means it is available. Then immediately you can set log of x 1, which means it is now not available for use. अगर log of x 1 है, कोई ट्रांजेक्शन T1 है, उसने लॉक ऑफ आइटम x को इनिशिएट किया, प्रोसीजर को, फंक्शन को, उसके बाद उसने ऑब्जर्व किया कि लॉक ऑफ x इज 1, इट मींस इट इज बीइंग यूज्ड बाय सम अदर ट्रांजेक्शन. तो क्या करेगा, इस ट्रांजेक्शन को आप एक लिस्ट में अरेंज कर देंगे, एक क्यू में अरेंज कर देंगे, राइट? एंड देन अगेन यू कैन गो फॉर द चेकिंग, कंटिन्यूअस चेकिंग. सो any transaction which is observing that log of x is 1, that transaction should be waiting on a queue. That is the philosophy, right? And that's the two way approach, right? अगर log x 1 है तो वेट करना है, log x 0 है तो यूज करना है, यूज करने से पहले आपको उसको 1 सेट करना है. That is the basic philosophy, right? Now after, so let's assume transaction T1 has observed that log of x is 0, then he will be setting log of x to 1 and then will be using. After going to these things, after using this variable x, data item x, the responsibility of transaction is to unlock this, right? Because that's how the transaction will be maintained, transaction processing will be maintained, concurrency will be maintained, right? So basically transaction T1 क्या करेगा, it will unlock the data value, it will set this log of x variable as 0, right? और उसके बाद इसकी responsibility next होगी, it will initiate, or maybe concurrency control system will initiate the sleeping transaction, वो transaction जो queue में थे, like transaction T1, T2, T3, something like that, right? So in the case of binary locking, we have a simple approach where we are saying whenever a transaction is trying to access a data value x or access data item y, any data value, first he should be checking the log of data item, lock of X, lock of Y, anything, and its status. And if it is observed that lock of X or lock of Y is 0, it means that transaction can use the data variable for their operation. And if it is not available, if it observes that lock of Y or lock of X is 1, it means that data item is not available. In that case, the concurrency control system simply add this transaction T1 to the waiting queue, right? तो ये तो एल्स केस हो गया. अगर ट्रांजेक्शन ने उस डेटा आइटम के लॉक वेरिएबल को ऑब्जर्व किया, इट इज 0, इट मींस दैट डेटा आइटम इज अवेलेबल, ही कैन यूज इट, ही कैन परफॉर्म सम ऑपरेशन आफ्टर सेटिंग इट टू लॉक x इक्वल्स टू 1, लॉक y इनटू 1. और ये सब करने के बाद आफ्टर परफॉर्मिंग हिज यूजुअल ऑपरेशन, अ ट्रांजैक्शन नीड्स टू सेट अनलॉक और लॉक x इक्वल्स टू 0, जिसके बेसिस पे दूसरे जो स्लीपिंग ट्रांजैक्शन है, वेटिंग ट्रांजैक्शन हैं, वो एक्टिव हो जाएंगे. सो दिस इज अ टिपिकल एक्सप्लेनेशन ऑफ बाइनरी लॉकिंग मैकेनिज्म. So in this case of locking approach, if you adopt binary locking is the first solution. Binary locking is the first proposed solution under this locking mechanism, right? But ये बहुत restrictive है, ये बहुत ज़्यादा rigid है. If a transaction is consume a lot of time, तो बाकी ट्रांजेक्शंस को बहुत सारा लंबा वेट करना पड़ेगा. So these scenarios are referred as a deadlock situation, or it may be referred as a starvation concept. Like if any transaction is engaging with data item for longer time, other concurrent transaction has to wait जब तक कि ट्रांजेक्शन T1 सब अपने लॉक वेरिएबल को 0 सेट नहीं करता है. तो हो सकता है कि कोई ट्रांजेक्शन इतना लंबा टाइम ले जिससे कि बाकी ट्रांजेक्शन स्टार्व हो जाए, टाइम आउट हो जाए, समथिंग लाइक दैट. So binary locking is too restrictive. It is having restriction based on only two variables, 1 or 0, or lock and unlock simple. So it is not considering the nature of transaction. That's what is the main limitation. In case of binary locking, we do not have any observation on the nature of operation. हो सकता है कि कोई भी यूजर केवल डेटा आइटम को रीड करना चाह रहा है, right? और हो सकता है कि ट्रांजेक्शन T1 has simply read the data item, he is not performing right operation, and again T2 transaction is also trying to simply read. So अगर read है तो उसको तो आप free कर सकते हैं. It is not required to engage this. So binary locking mechanism is not considering these nature of access on the data item. It is simply assuming that whatever type of operation user is requesting on the data item, it should simply hold the data value for a while, for using the data item X, and after completing all these any kind of operation by transaction T1, he can release it, right? So to be very simplistic explanation, you can read out these steps involved. So for binary locking, there are some algorithmic explanation is also given. So like it is kind of rule also. So if you see a transaction T, any transaction must issue the operation lock. So these are the statements which we have taken as a explanation also in the previously. So we have discussed possibly all the cases. So these are the rules actually which are framed for binary locking mechanism. So it is like a transaction T must issue the operation lock before any read X or write X operation are performed in T1. That's what I have said, that it is nothing to do with the type of operation. So whenever a transaction T tries to operate on a data value X, it should immediately issue lock item X. A transaction T must issue the operation unlock after all read and write operations are completed. That's what we have said. So after completing all the transactions, you should be issuing the unlock function. And unlock function will unlock item X function will simply set a lock of X as a 0, which means that data value is available for use, right? And there is an instruction like a transaction T will not issue a lock item X operation if it is already hold the lock on item. So it is some kind of self-observation that if particular transaction is already using the data item X, then he cannot issue again a lock item because it is already set it as 1, right? So you cannot have a self-lock mechanism. Similarly, the last instruction you can read, a transaction T will not issue any unlock operations unless it is already hold the lock of S. Yeah. So right. So you cannot. So if any transaction who is not using the data item X, if any transaction who is not using the data item X cannot issue unlock, right? तो अनलॉक वही कर सकता है जो उसने उसको लॉक सेट किया है, जो इसको यूज कर रहा है। ऐसा नहीं हो सकता कि ट्रांजेक्शन T2 या T3 जिसने अभी डेटा आइटम X को एक्सेस ही नहीं किया या कि लॉक ऑफ X इशू ही नहीं किया, तो वो बेसिकली उसको अनलॉक नहीं कर सकता है, राइट? So this is something a basic philosophy of binary locking, but because of some restrictive nature, complex nature, you can say, basically these locking mechanisms are not so that successful, not that much successful. So they have proposed a new version of it, locking mechanism, binary locking mechanism, and it is called you can say shared exclusive locking, right? Shared exclusive locking basically have this philosophy that okay, you need to, so in case of shared exclusive locking mechanism, the whole philosophy of locking is okay, is the same, that okay, we have two-phase locking and locking, but one additional thing has been introduced here, that is you need to see the nature of transaction, you need to see the nature of operation of the transaction. Based on that only we will be issuing the lock variable or lock status, right? So now in the case of binary locking, we have two possible states for lock variable, that is, I mean, locked or unlocked, right? So if you go to see what is the current status of lock of X, it means it is having two possibility, that a variable is 1 or 0. So 1 indicates that a data item is already being used, 0 indicates, so lock variable 0 indicates it is available for it. But in case of shared exclusive locking mechanism, which is the improved version of binary locking, you can say here we have three possible state for a lock variable. So lock of X could have three possible value, like it is either it is read locked for read operation, it is locked for write operation, or it is available, right? So now we, just because we are having three different status, three different so values for a lock variable, it means we need three different operations, right? Three different operations to update the lock variable, right? So it is, first is called read lock X, second is called write lock X, and third is called unlock. So like in case of binary, we have only two operations. For a first operation of first function is called lock item X, and second operation is unlock item. But in case of shared exclusive mechanism, we have probably three different operations. First operation says read lock X. So read lock X is first function, second function is write lock X, and last function is unlock X. So let's have a brief idea about these functions which will be used or which will be called by the transaction at any point of time whenever they want to access a particular data item, right? So let's see how a read lock is arranged. So suppose this transaction T1 is trying to access the data item X in the database system or in the transaction processing system. So he will issue. So suppose transaction T1 is going to operate X operation. Then he will be simply going to see if lock of X is unlocked, right? So ये states हो सकती हैं कि किसी point of time पे lock of X, डेटा आइटम X के जो लॉक वेरिएबल है उसका स्टेटस तीन चीजें हो सकती हैं, कि वो रीड लॉक्ड है, राइट लॉक्ड है और अनलॉक्ड है। तो जैसे ही हमने कोई ट्रांजैक्शन इनिशिएट किया एंड इफ वी आर ऑब्जर्विंग दैट रीड lock of X is unlocked, it means that the data item is free, it is available for use, you can access it, right? अब क्या है कि उसमें आपको देखना है कि if lock of X is unlocked, it is available, then you need to see what is the nature of your operation. Then if you're trying to perform a read operation, right, you can simply say, you can simply set as a read logged, right? So you can see the flow of operations also, right? And you can see in the second statement, it is that lock of X equals to read logged. Then you need to update or assign a value to a variable called number of read of X. So now you are maintaining additional variable, which is named as number of reads. So we are basically maintaining the list of number of reads on a data variable. So number of reads on data value X equals to 1, because ये data value अभी basically free था और now we are trying to read it simply. तो अगर आपके transaction केवल read है तो आप इसके read number of reads को improve कर देंगे 1. और उसके बाद आप भरेंगे. That is one possibility. Second possibility, that if your transaction is trying to read the data value x, and that data value is already in the access by some other transaction, और log of x की वैल्यू अगर रीड लॉग्ड है, अगर log of x की वैल्यू रीड लॉग्ड है, इट मींस कोई दूसरा ट्रांजेक्शन ऑलरेडी इसको रीड कर रहा है. तो उस केस में क्या करेंगे आप? सिंपली आप भी रीड करना शुरू कर देंगे, और क्या करेंगे, नंबर ऑफ रीड्स को इंक्रीज कर देंगे एक से, बिकॉज you are the second transaction who are trying to read it. Third possibility ये है कि if log of x is called unlocked, right? So if particular data item is basically write logged by some other transaction, basically, then you need to wait for your turn, basically. So you can, our transaction control system will be putting this T1 transaction into a queue, right? So basically it is little, I mean, this shared exclusive approach or shared exclusive locking mechanism is slightly flexible, because it is having restrictions only if lock of x is in the status of right. Otherwise वो open है. If any point of time transaction any transaction T1 is observing that lock of x is in the state of reader logged or unlocked, तो आप उसको access कर सकते हैं. लेकिन अगर lock of x की value जो है right logged है, it means someone is trying to update it. उस case में you have to wait it. That's the simple philosophy, right? So whenever you see you are trying to observe that, okay, you are having tendency of locking the data item for update. So if you see if lock of x is unlocked, so lock variable of x is unlocked, and you are trying to write a data operation, then you need to set as a lock of x as a write log. अगर आपके ट्रांजेक्शन में एक ऑपरेशन है और आप ट्राई कर रहे हैं कि मुझे ऑपरेट करना है और उस डेटा आइटम पर उसको अपडेट करना है, then you have to access the lock of x variable. आप देखेंगे कि वो unlocked status में है, it means you can operate on the data item, and based on that, before operating it, you need to set as a write logged. जो दूसरे ट्रांजेक्शन है उसी मोमेंट में जो ट्राई कर रहे हैं, they observe that okay, this lock variable is having this status of called write logged. It means some transaction is trying to update it, so you have to wait, right? Similarly, after doing all these operations, write, read, and simply unlocking, you need to unlock it simply, right? And if you observe that if any transaction T1 is checking the lock variable x status and see lock of x is write logged, right? Lock of x is write logged, then it will simply set as a unlock. It means that transaction is available for the transaction. If it is a logged for reading, if some other transaction is trying to read it, and your transaction is now, this new transaction is trying to see and unlock it, he will simply reduce the number of counts. That's it, right? So it is having this philosophy of three functions for this shared exclusive approach. And as same as the binary facing mechanisms, we have four statements, four rules which are defined for these transactions, these shared exclusive locking mechanism. So you can read here, a transaction must issue a operation read log or write log before any read item x. So that's what it is said. Whenever a transaction tries to access the data item x, you need to issue a read or write log variable function, right? Now, if a transaction is trying to access it, it must issue the operation write log x before any write operation. That's what I have said. So whenever your transaction is trying to have the tendency of write operation x, write operation on data item x, it should issue write item x, write log actually. So write log function he should be initiating, right? Similarly, if a transaction must issue the operation unlock x after all the read and write operation are completed. So this is something common sense, that whenever after completing all the read and write operation on data item x, you should call for a unlock. It is similar to the binary locking mechanism also. Similarly, if you see a transaction will not issue any read lock operation if it already holds a read shared log or write item. So basically, this is something you can say this is something we are observing as a flexibility which we have got in the uh, shared exclusive locking mechanism, right? This was not available in the two-phase binary locking system. So with these basic conditions, we understood that how this locking mechanism works. So we have two versions for locking mechanism. One is called binary locking, and another is called shared exclusive locking. So basically, these locking mechanisms are designed to control these transactions, their access into the system, access into the database system, and concurrently, they cannot update the value of data item without updating the log variable. So we have two-phase approach. In the first phase, we have got this idea about that how to set the lock on the data item, any data item. So suppose transaction T1 is trying to access X, Y, Z, any data variable. So once the transaction get accessed, got permission to access the data variable X based on the current status of lock variable. So after accessing the data variable X, it will simply put a lock on the data item so that other concurrent transaction might not access the variable. And after accessing or completing all the operation, he will be releasing it. He will be unlocking it for the use of other transaction. That's the basic philosophy of locking mechanism. So we have two-phase lock and unlock, and so there is an extension in the basic locking protocol proposed in the shared exclusive, where we have a specific locking mechanism for read and write operation, right? So that is something. So we have two versions. So that is in with this lecture. Actually, we have taken this concept of locking, and in the upcoming section, upcoming classes, we will be discussing the second approach, which is called time stamping, right? So time stamping is another solution, another approach, right? Because in many scenarios, in many cases, we have got an observation that this locking protocol is facing or suffering from the problem of starvation. Starvation is one important phenomena. You can search in the internet also that what is the starvation. So starvation is a scenario where in a database system or in any operating system, we are getting a lot of processes available. They are waiting for some resource, and due to this longer engagement with a process, that resource is not available for other processes, right? So suppose we have got one printer in the house, and we have requested, so that printer got request for document printing from two different individuals, and just because one system has sent a request of printing 1,000 number of pages, other request of document printing get stopped. They are waiting for indefinite, they are waiting for longer time. So similarly, in the case of time stamping, in case of locking mechanism, because locking mechanism is something, it engages all the privilege. It will have all the privilege of some data item for a longer period of time. So it may also leads to, so this locking mechanism may leads to this scenario called starvation. So to deal with this situation, they have proposed some kind of enhancement in the time stamping, and they claim that a time stamping algorithm or time stamping approach for concurrency control will not suffer from this issue of starvation, and it will serve some kind of flexible solution for concurrency control. So we will be discussing time stamping approach in the next class, and you must be looking into this solution called time stamping, right? So with this, I'm closing today's lecture. If you have any specific doubt, you can share me.